Hi, I'm Dustin with Pro AV School. In this video, I'm going to show Crestron programmers how you can build a SIMPL plus XML parser so you can pull some basic data into your programs to use for different parameters. This is part of a pre-recorded course called TLDR Plus. I'll leave some information below, but follow along and I'll show you how I do it, and I'll also give you a download link where you can get the example program. So this is, say that this is a file that's going to be on our processor, and it's going to have some properties that we're going to display on the touch panel. So we have a room name, we have a room phone number, and we have a support contact. That would probably be a number, but I'll just do it as an email address just because. Now you'll notice you have the open tag, the close tag, and the tag can be named whatever. It doesn't matter. It just has to have a corresponding close tag. So notice that this is all kind of on the same level of the document, and our parser is just going to basically pull out the tag or look for the tag and then get the value for the tag. So let's dive into how we would actually program that. The first thing to note is that this module that we're building right now, I talked about pulling from an XML, but I'm still not pulling it from a file. But the file part we're going to talk about. But for now, let's just look at parsing the data. And we're doing it in kind of a simplistic way. I'm going to assume that there is a carriage return, hex 0D basically, 0D, 0A. We're just going to look for 0D at the end of every line. And our data is going to be formatted that way. These tags, we're going to actually use parameters in SIMPL to match up the tags so we know where we want to output the string. And also the way that I capitalize this, I'm not sure if that's actually typical for XML. It might not like to use capitalization. I just did that for clarity because that's how I've been kind of naming my variables with camel case. So anyways, let's start here with what the end result is, I guess. And that's this module here. So I've got data in, that's what's feeding this. We're going to basically feed this in line by line from debugger for now, and then we'll tack on the file stuff later. So we've got data in as a string, and then we've got our three tags. Now note, because we didn't move this input, it writes over the name of it there. That doesn't really matter. You still see tag 1 as the prompt here. I was going to change it, but I decided to just leave it because it's simpler. So we've got the three parameters. Those are the tags we're looking for, and these are the strings. So that corresponds to this, where we'll have the three tags and the three strings. This is going to be as a string, and that one as well. So let's see how we accomplish this. So I've got this constant of max records, and I did that so that later on we could change this to be more than just three items. I've got data in as a 255 character buffer, which is pretty much the max that can be sent in at a time from SIMPL anyways. And then I've got an array of values, that's these three. Max records, again, that's going to be 3, but that's scalable as we adjust that. Then I've got string parameters, so that's these three here. Max records, and I've got a size of 50 characters. So these must be shorter than 50 characters, or maximum 50 characters. And that should basically be good. Now, I've decided to create a structure, and that's just going to contain my tag name and value. And those are both strings. The value, I've limited that to 200 characters. And right here is where I declare type record. So you see where it's, if we're just declaring declaring a string, it would be string, which is the type, and then the name of the string, and then the size. With a structure, this is the type. So we're doing a type record, and then we're giving it a name records, and then the size, the number of records that we're going to contain in this structure is going to be this max record, so there's going to be 3 of them. Now it gets a little bit more complicated. So the first thing that we want to do is when the module starts up, I want to read these 3 parameters into our record structure just to kind of hold basis there, because we'll fill those in, check them and fill them in later. So down in function main, I've got a couple things happening. So I've declared a variable. That's what we're going to use as the data that comes in that we're going to parse out. And we're using this wait for initialization complete because I want to do something. I want to read the parameters. And what this function does is, even this has to be a little bit more complicated, because we need to make sure we don't have duplicates, because that could really screw us up, because we're going to try to match based on these tags. So what we're doing is we're going to go through, we're creating a loop going from 1 to the max number of records, so 1 to 3 essentially. And then we would just put the value into each slot, each tag name slot, but we've got another loop in here, a nested loop, working on another variable y as a counter, that for every step we're going to look through this array again and make sure that there is nothing existing for this tag name. So for example, if you had room name, then you had room name, this will error out basically. So if it finds a match that's already there, and there shouldn't be a match because they should all be unique. So if it finds a match, there's a problem. So we're going to do a trace of the problem. I'm also going to generate a user warning. This is a new one that we haven't really looked at yet. This basically writes to the error log of the processor, and that's something that will basically create that message light, which a lot of things kind of create that message light on processors, so it might not be the best thing, but if you're checking and you're not on the console, you'll still be able to see this error warning, so that it's an indicator that there's something wrong. And I wasn't even going to do that, but the reason for kind of drilling that into you or mentioning it now is, if you've got something like this where it's kind of user supplied inputs, this will be possibly something you're passing to another programmer, or even yourself in the future, where you might screw it up by putting the same name. You don't want it to just work and then you get weird results. If they match, there's going to be some weird results. It'll only match to the first one. So this doesn't stop the program from running. There isn't really a way that I'm aware of anyways to like halt the execution of the program. We just generate that warning, and then everything's going to be kind of unknown from there. So if we've gone through, and as long as there's no error on our check of the current record, then we write it into this structure. And you might have to spend some time looking at this to really understand how it's working, because just staring at it here, it's a little bit complicated. But this is the checking part. This is what we would do if we weren't checking. We would just put these in. So records X, which is our main counter, which is going to be 1 through 3. Records 1 dot tag name equals tag X, and that tag X is coming from the parameter. So this basically just populates our structure. It doesn't give us a value. The value will be undefined, or it'll be like an empty string, but we'll fill it in with all the tags that we've included here, and then we're going to be watching for those basically. So after that, we go down here, and then we have kind of the meat of our parsing, while 1, so that's always going to keep looping. We're using the gather function, so that's a blocking function. So data equals gather. Gather will sit and wait until it reaches the end of a string, or end of a line, basically a carriage return. So it'll wait until it gets a full record there, and then it will push that to process data, and then it will clear the buffer, and then go back again and wait for the next one. So process data is what's doing most of our stuff. So we pass that string in, and we've got position as an integer. That's an array, just so I didn't have to have a few different variable names. It's just a couple different spots that we're gonna kind of flag. The XML tag we're gonna get, the data we're gonna get, and a temporary string that we're using, and you'll see that later. So first thing, we're gonna say what we're processing. Then we're gonna look, remember this is the type of data we're looking for. So we're gonna look for the first, I guess that's a less than symbol. And we'll put a marker on there, or a flag, that's position 0. And it might not be at the front of the string, right? In this case it will be, but if you had some extra data there, or extra information there, we can't guarantee it's going to be right at the start point. So we got to search for that. Then if we find it, let's see here. Yeah, so if it's not 0, so this find function returns 0. I tried to actually put this find into the if statement here, and I was having some trouble, so I'm not sure why that wasn't working, but I needed to assign it anyway, so I did it this way. And so we've got an if. If it finds it, then good, it does its thing. If it doesn't find it, we could have done another trace. I kind of forgot to do that. We'll just kind of ignore it if it doesn't find it, I guess. Probably best to have some sort of a warning to the user, or more the programmer, because the user themselves. I guess like the user, is it the user of the system or the user of the module? So writing something to the console isn't something for the user, it's something for the programmer that's actually putting things together. But anyways, so then we're looking for the closing tag, which would be this. Then we're going to extract with mid. We're going to extract this name here. We're going to do a trace of it. Then we need to generate a string adding the slash to indicate that it's a closing tag. So we're going to basically find the next closing tag of this name. So we've got a string now that will have that name. And one thing I should just back up just a quick second. This position 0 plus 1 and position 1 minus position 0 plus 1, it's just because the first find is here. So we actually have to start extracting it at the next spot. And the same thing, we found this, but we got to go, we're calculating the length. So we got to go less this, but then we have to add 1 because we've kind of shifted it all. So one thing I've found when playing around with these, sometimes you have to, if you're not that good at the math of it, which I kind of suck sometimes, and maybe it's because it's late at night when I'm recording this, but sometimes I have to run it a few times and adjust because I've offset a little bit. And that's why having these trace statements, when you're developing it, make it handy to figure out what's actually going on. So now we found basically markers telling us where this data is going to be. And this is, we looked at an example like this before where this is a variable length. We can't determine the number of characters it's going to be. So we have to base it off of where this stops and where this starts. So that's extracted here. The other thing we're looking for, I guess, is to make sure that we have the end tag. If it's not in this this data set that we've passed through, then it's going to error out again. And this return statement here, it'll stop executing this function and return back to where it called from. And essentially it'll do nothing. It'll just puts it back and ignores it, or drops it, I guess you could say. So assuming everything is good, then we take our data, which is a local variable of a string. and we want mid, and we're going to extract this stuff here. So that's all good. Now we call this add record function. We know what the tag name is. Again, that's this, and we know what the data is. So add record, we pass those values in, and it's going to look through it and try to find the tag name. Now, I didn't really do an error condition. If it doesn't find the tag name, we just ignore it, basically. But if this tag name has already been defined, and that's from the parameter, remember we read that in, then we add the value to that record. So we're just searching through these, basically. And this is where structures are kind of cool and kind of good to use or handy to use, because it's an array of stuff. So you can loop through it or iterate through it pretty easily. You don't have to do a bunch of if statements against a bunch of different data, basically. So if it has been updated, then we have this update flag. That's just an integer. We're going to set it to 1, which it would normally be 0 after we declare it. And that just lets us know that we have to refresh the record. If not, then if it wasn't found, then we're not going to refresh everything. So refresh records, that basically is just pushing this. It's going through the structure, looping through it, and updating the output of the module to match the values that are found. So that's basically, in a nutshell, how this thing works. And now I've loaded it, so let's take a look at how it behaves. Restarting the program, and you'll see here, read parameter. This is stuff that came in from our trace that happened on the function main. So we've read room name, room phone, and support contact as keys, which is good. And then we can start putting our information in. So let me reconnect to debugger, or reconnect the debugger to the actual program. So we've got that connected, and now we're going to send this data, this first line in. And I'm going to just copy and paste this, and then backslash, I'll just do \n for new line. So a number of things happen. These are a bunch of trace lines. Some of them are just for my own debugging, but we're processing this line. So it's gone through the gather and it's got into the process data function. It's found these positions. It's found this tag, room name, and it tells us that it added a record of tag name and the value, or tag name of room name, and the value is Juniper. And then my serial output of the module says Juniper. And because we're matching things based on tag, if I change this to, say, Jude, I change the name to Jude and send the same string, it will replace that in the structure. So it's using that same tag. And I could do the same thing here. You see the room phone updated. And I could do support contact. And that one has updated as well. So now if we wanted, let's just try this. Make it a bit smaller. I got to make sure that it's not more than 255 characters. But we might be able to send this whole thing in. Column 123 here. Let's just see. 122 characters selected. So we can send these all in at the same time. We've got that 0D between it. We'll just do something different. We'll go ABC. Let's go like 9999. Just so that we can see a change. abc@room.com. Let's copy this, and we should be able to take up to 255 characters. And we need the trailing 0D as well. So that didn't work. So the reason that didn't work. So one thing you got to be careful with when building stuff like this is if you expect it to be used different ways, you need to build it more robust. If you can control how the data is input, then you can kind of make it more simplistic. So in this case, what happened is sending it through here, our gather basically grabbed the first one, and then our clear buffer cleared the rest. So we would have to re-engineer how the gather works, how this part works, to be able to take those in multiple chunks basically. And I'm not going to do that right now because, like I said, this already took a bunch of time to just go through this basic example. We've got our parser working, so now we're going to attach that to a file read and kind of tie it all together. So what I've got here is I've got a digital input. That's this here. Let me make this a little bit easier to see. The digital input is read. And we've got a press. So this is the file operation part of it. This is really the only thing that we're adding. And this is actually similar to reading the file. So what I've changed from this, I've got it read only and text. The file name is changed to text.xml. The extension doesn't matter. You could call it whatever you want, but since it's an XML file, we're going to call it .xml. And this file here, I've saved it as .xml. And I've also loaded it, I'll show you here, into NVRAM under the test directory, which is the program name tag. Again, to reiterate, I'll just show you in SIMPL. That's this here, the program ID tag. So we've got the test.xml file. And what we're going to do this time is, rather than trying to read a big chunk of it, because we're not going to assume that we can fit the whole file in. Now we could, because we know that it's not that many bytes, but say it's huge. Rather than trying to put it all into one read operation, what I've got here, this is a little bit different than what we've seen before, and it actually works quite well. So I've got a while loop, and while file read, the file handle, because we've opened it, and data byte, that's just a string that's holds 1 byte, and specifying 1 byte basically, number of bytes 1, while this is greater than 0. So while the file return operation returns greater than 0, meaning it's not at the end of the file yet, then keep doing this. So we're going to add, we've got this buffer, we're going to add that byte to the end of the buffer. And this is the same thing as what we had before. This is what we had before in our function main. We had a while 1, and then we gathered up to 0D. Then we processed the data and cleared it. In this case, we're building up the buffer by adding 1 byte to it every time, and then we're searching for, finding if it has 0D in that buffer, and if it does, then process the buffer and clear out the buffer. I could have done clear buffer as well, but I did it this way. So this does this exact same thing that this, or basically accomplishes the same thing that this did. And it's going to process the data exactly the same way. It's sending 1 line of formatted data. So it's going to send either this, or this. And it's going to basically read the file byte by byte, build up the buffer until it reaches the end of a line. It's going to send that, clear it out, and then keep going until it reaches the end of the file. And we still need this file function main, but we're not doing anything other than reading the initial parameters. Remember these guys here, the tags, we're going to read those into our structure. But most of this is the same as the XML parser, and the reader thing is the different different part. So now I'm going to open up Debugger. And I've already actually run it once. Let me restart the program. I'll have to reconnect Debugger as well. But you'll see when it restarts, the first thing it'll do from function main is it will load those parameters. Read parameter room name into slot 1, room phone into slot 2, support contact into slot 3. So those are our three, that's the array of structures that we've got. And I have to reconnect this here. And then all we do is do read. And it goes through, and now all this data is being pulled out of the file. So it's doing the same, these are the same traces that we had in our parse algorithm. And we've come up with the room name as a string, the room contact, and the room phone all as strings. So this is tying it all together. Like I said, the parsing is what we talked about. This parse routine is exactly the same with all the stuff that we had going for it. And it's just the reading is coming from this function here. So I'm going to post this example as well. It's a little bit complicated, but basically we're just building sequentially on things. If you found this useful, please like the video and subscribe to the channel. If you have any comments, any thoughts about what I've done here, or you want to see some other stuff on this channel, please leave a comment. I see all of them, and it gives me some good ideas of how I can create content that will help you move forward in your Crestron programming career. Thanks, and we'll see you in the next video.